For this video, we'll be discussing dividing fractions. These can be dividing fractions with whole numbers, dividing fractions with mixed numbers, or dividing just regular fractions. We're going to begin with dividing a whole number by a fraction. So we are going to solve this both mathematically and using a model. So for this first part, we're going to change this division fraction into a multiplication sentence and multiply this first value by the reciprocal of the second value, also known as keep, change, flip. So what that looks like is we will keep this first value alone. So we will keep it as 9. We will change the division to multiplication, and then we will flip this value. This value, we will find its reciprocal. So 4 over 3. Now, as 6th graders know, we like to multiply straight across, but this 9 on its own, we can't do that. So we're going to put it over a 1, and the only point of that is being able to multiply straight across. So 9 times 4 is 36. 1 times 3 is 3. 6th graders, we know that this is improper because the numerator is bigger than the denominator, so we use long division to fix that. 3 can go into 3 one time. Bring down our 6. 3 can go into 6 two times because 3 and then 6, when we use our skip counting, that's twice. 2 goes out the top, 6 underneath, no remainder, so the answer is 12. We can also solve this using a model. So the first thing that you would do is you need to draw a rectangle. We can call this an area model. We can call this a tape diagram. What we need to do is represent this 9 and this 3/4. So we're going to break our rectangle into 4 sections, with 3 of them being equivalent to this value of 9. So when we're solving this, we're trying to find out what this entire rectangle would be equivalent to. If these 3 sections together make 9, we can think of one section as 9 divided by 3, which is 3. So each of these sections would be 3. So 3 plus 3 plus 3 gives us a value of 9. If this section is 3, then this section over here is also 3, meaning this entire model is equivalent to 12. The next type of example that we're going to do, we are going to solve a fraction divided by a whole number. So we are going to do 4/6 divided by, it would help if you could see it, 4/6 divided by 3. Again, we are going to solve it mathematically first. Again, we're going to change this to multiplication and multiply by the reciprocal, aka keep, change, flip. So we're going to keep the first value, change it to multiplication. The reciprocal of 3 is 1/3. Because like before, we can put this over 1. It doesn't change this value. It just turns it into a fraction that we can then flip and manipulate. Then we get to simply multiply straight across. 4 times 1 is 4. 6 times 3 is 18. This is not improper, so we don't need to change it into a mixed number. We can also solve this problem using a model. So we are going to create this model. Again, an area model, or we can call it a tape diagram. The first thing that we need to represent is the 4/6. So I'm going to create 4/6. I have 6 sections. I'm shading in 4 of them. When we're dividing, we are creating equal groups, or we're cutting something up. So then I'm going to cut this model the other way into 3 sections. The answer then is one of those 3 sections. So if this was an example and this was 4/6 of a brownie and 3 people were sharing it, they would take what they had and cut it into 3 equal size groups. And one of those people would get this entire section here, which is 4 out of 18. Okay, moving on. We are now going to solve a fraction divided by a fraction. So first we're going to solve 12/4 divided by 3/4. As always, we can solve it mathematically, and that does not change. We would do keep, change to multiplication, and flip it to get the reciprocal, and then we're going to multiply straight across. This becomes 48. 12 times 4 is 48. 4 times 3 is 12. This is improper because this number is bigger than this number. 12 can go into 48. We're going to skip count by 12. That's 1, 2, 3, 4 times. There's no remainder, so the answer is just 4. We can also solve this using a model. So in this case, the modeling is kind of different. We're so used to using our denominator to show how many pieces we have. But with this being improper, we know that we're going to need more than 4 of those pieces. So what I'm going to do is I'm going to draw this area model with 12 pieces, which is our numerator. And I'm going to label it that this entire thing is worth 12/4. Now, because these denominators are the same, that means that we're working with the same size pieces. So we can almost ignore this at the bottom and think of this as 12 divided by 3. So what we can do, we have our 12 sections, and we need to break it up into groups of 3, 3/4 size groups. So I have 3 here, another 3, another 3, and another 3. Each one of these being worth 3/4, 3/4, 3/4, and 3/4. So 3/4 can fit into 12/4 4 times. I have 4 groups here. I also want to point out that when we are doing, and I should have pointed it out before, when we are doing keep, change, flip, and we notice that we have the same number on top and bottom, we can eliminate them. So if we wrote this out, and friends, remember we did this with when we're eliminating zeros, I can get rid of this 4 because I find it on both the top and the bottom of this fraction and leave it as this. 12 divided by 3 is 4. So that, again, we get 4 as an answer here, 4 when we model it, and 4 when we simply just multiply straight across. Now we're going to do another fraction divided by a fraction, but this time our denominators, because if you notice our denominators were the same, our denominators are not going to be the same. You will notice that this only changes what we do for the steps of the model. So our problem for this one is going to be 6/5 divided by 1/2. Again, doesn't matter if the denominators are not the same for the mathematical way of solving it. I'm just going to do keep, change, and flip. I'm going to multiply straight across. So 6 times 2 is 12, and 5 times 1 is 5. So that's improper because this number on top is bigger than the number on the bottom. So I'm going to do long division to fix it. 5 can go into 12. Let's show my skip counting just in case. Well, 15 is too big, so we're going to use 10, which that would be 2 groups of 5, so we can go in twice. 10 underneath. We have a remainder, so remember, friends, our remainder becomes our numerator, and 5 becomes it stays as our denominator, which we got from here. So 2 2/5. Okay, we can also model this one as well, but in order for us to be able to model it, the denominators have to be the same because we need to be working with the same size pieces. So friends, remember, when we need to find the common denominator, how do we find a common denominator? We skip count. So off to this side, I'm going to skip count by both denominators so that I can find my common one. Clearly, my common denominator is going to be 10 because that's in both of my lists. In order to get from 5 to 10, I multiply by 2, 1, 2. And to get from 2 to 10, I multiply by 1, 2, 3, 4, 5. I'm going to apply this information that I saw from over here over onto my fractions to change them. So 5 times 2. And whatever I do to the bottom, I must do to the top. And the 2 times 5. That's going to give me 12 over 10 divided by 5 over 10. And now that my denominators are the same, I will be able to create my model. So like before, as we noticed, this is improper. Typically, we would have 10 parts and shade in 12 of them, but that's going to create a model that is bigger. I would like, though, to show you that you can still create it without just 12 parts. So I either could do it with 12 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I'm adding extra stuff I don't even need. 12 parts, circling groups of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have 2 whole parts, 2 whole groups. And then, friends, we have this little part over here, and I only have 2 of those sections. So if in each of my groups there needs to be 5 to be a complete group, and I only have 2 of the 5, these 2 pieces are then represented by the fraction 2/5. Because I don't have a complete group of 5, I only have 2 out of the 5 I need to have a complete group. So 5 tenths can fit into 12 tenths 2 full times, and then it can only fit in 2/5 of another time, of another group. But if the way that this setup looks weird to you and you want to see that I could represent it the way I would normally. Normally speaking, I would have 10 sections. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This whole thing shaded in. And then I would have another one because I need 2 more of those pieces. So again, 9 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. But only 2 of them shaded in this time. I still would go through and circle groups of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 holes. And then I still have these 2 pieces left. So it really is up to you on how you want it to look. I could have done the same thing with the previous example. Either way is completely acceptable. Okay, we have one last problem that we're going to do. And this is when we are working with a mixed number. So if we have a problem that is division, but we have either 1 mixed number or 2 mixed numbers in this problem, we can't really do keep, change, flip in this way. It is pretty impossible because I need to be able to multiply straight across, and I can't with this. So what I'm going to have to do, my first step, is to turn this mixed number into an improper fraction. So in order to do that, we multiply by our denominator by our whole number, because this is going to create how many of those thirds that we need to have 6 wholes. And then we're going to add it by our numerator. So what this looks like is 6 times 3 equals 18 plus 1 equals 19. This string of math then becomes our new numerator, and our denominator doesn't change at all. So here's one thing I remember we need to make sure that we do. You need to take this improper fraction and insert it back into your division problem. Skipping this step sometimes allows you to make silly mistakes. So then I'm going to take my newly created division, which isn't a new problem, it's just a new way of looking at this. Remember, friends, I used to always say that I am Miss Joyner, I'm also Taylor, I'm also mom. So these 2 things are equivalent to each other. They're just a different way of saying it. So what I'm going to do next is I'm going to do keep, change, flip. So I'm going to keep my first value. I'm going to change this to multiplication, and then I'm going to flip, find the reciprocal of my second value. Again, I get to multiply straight across. After I change this mixed number into an improper fraction, this is not any different than what we've been practicing. So 3 times 2 is 6, It's okay if you can't do 19 times 4 in your head. And it's always best to double check yourself anyway. So 4 times 9 is 36. 4 times 1 is 4, plus 3 is 7. 76 goes on the top. Again, this is improper. So what do I have to do? Long division. We don't like improper. We have to fix it. It's not wrong, but we just don't prefer it. 6 can go into 7 one time. Bring down my 6. 6 goes into 16. Oh, I don't know. I'm going to skip count. It can only go in twice. My remainder is 4. So I have 12. And remember, we use our divisor, which is our denominator stays the same. So my final answer is 12 and 4/6. Remember, friends, we are going to be having a quiz over this on Monday. So please, please, please watch this video multiple times.